So students, in this question of EC 2017, you find that there is a matrix of size 5 by 5 and you have to determine one of the eigenvalues. You can determine one of the eigenvalue by using a minus lambda I equal to 0. That will result in a polynomial of degree 5, and by solving that polynomial equation, you can determine the value of lambda. However, that will take a much time. Rather, what you can observe in this matrix is that here along the first row the elements are 1, 2, 3, 4, 5, and in each row these elements 1, 2, 3, 4 and 5 are placed in different orders. Therefore, you note that the sum of the elements along any row is equal to a fixed number. Here the sum of the elements along the first row is 5 plus 4, 9, 12, 14, 15. And this is true for each and every row of this matrix. You note that since the sum of the elements along any row results the same value, that value must be an eigenvalue. Therefore, what is an eigenvalue of this matrix? 15 is an eigenvalue of the matrix. Choice A is the correct choice. Now move. So students, you can move to this question from W 2017 now. In this particular MCQ of 3 by 3 matrix is given to you. It is also given that here the three distinct eigenvalues are there, and one of the eigenvector we don't know corresponding to the which eigenvalue, but we only know that the eigenvector given to you is 1, 0 and 1. Your task is to determine another eigenvector. You know it well that the eigenvectors can be determined by using Ax equal to lambda x. The resultant system of equations can be used to determine the eigenvector. However, one can employ some shortcut to this problem. You note that this matrix in particular is a symmetric matrix. Why? Suppose this is the principal diagonal, and in this case the upper triangle is exactly same as that of the lower triangle. The elements along the principal diagonal doesn't matter. This matrix becomes a symmetric matrix. And you know, if I find that a matrix is symmetric and if you find that the eigenvalues are all distinct, As for example, suppose you take two distinct eigenvalues, lambda 1 and lambda 2. Suppose that corresponding to lambda 1, the eigenvector you have x1, y1 and z1. And corresponding to lambda 2, the eigenvector that you have, it is x2, y2 and z2. If the matrix is symmetric, means entries are real. So one should say that the matrix is a real symmetric matrix like this. And here the eigenvalues are all distinct. In this case, the dot product of these two vectors must be 0. In other words, you can find that x1 x2 plus y1 y2 plus z1 z2 equal to 0. That is the result that you have. So what you can try, you have your x1 y1 z1 over there, and let us find out the vector or the choice for which the sum will be 0. What you can note is that suppose choice A, you find that 0.1 plus 0.0 plus negative 1.1 is not equal to . So students, we shall determine the solution to this problem from W 2017, and to this question a 3 by 3 matrix is given. We have to determine the correct set of eigenvalues. You know, since the matrix is a matrix of order 3 by 3, there are exactly 3 eigenvalues. You also know that for any matrix, the trace of the matrix is equal to sum of eigenvalues. Now, what about the trace of the matrix? You know, trace means the sum of the elements along the principal diagonal to any square matrix. Therefore, the principal diagonal means 0, 0 and minus 4. Therefore, the sum of this matrix is equal to minus 4. Evidently, the sum of eigenvalues must be equal to minus 4 in any of these choices. You may note that in the first case, the sum of the eigenvalues is minus 4. Whereas in the second case, the sum is not minus 4. For the third case, it's not minus 4. For the fourth case, the sum of the eigenvalues is not minus 4. So the sum is minus 4 is only applicable to the first choice, and hence without any computation you can find that choice A is correct to this question. Now move to the question from Mechanical 2017. To this question, it is given to you that a 3 by 3 matrix is there and you have to determine the product of eigenvalues. We all know that the product of eigenvalues, is equal to determinant value of the matrix. Since the matrix is P, we can denote the determinant value as mod P. Now what is the determinant value? You can expand the matrix along any row or any column of your choice. However, you should expand the matrix along the row and the column that has the maximum number of zeros. Therefore, you can plan to expand it along the first row since it contains 1 zero. If you expand it along the first row, you have mod P equal to 2. This element multiplied by its cofactor. What is the cofactor? Minus 3, 3, 2, minus 1. Clearly, minus 1 to the power I plus j shall produce 1 over here. What about next? 0. We are ignoring it. The next element is 1. It is plus again. So for 1, the minor is 4 minus 3, 0, 2. 4 minus 3, 0, 2. So how is it? You find that it is minus 3, that minus 1 is 3, minus 3 dot 2 is 6, plus 1 into 4 dot 2 is 8. So finally, you have 2 into negative 3 plus 8, that is 2. So, as per this formula, the product of eigenvalue is equal to 2, equal to the determinant value. Evidently, the product of eigenvalue is 2 without any computation.